Okay, so it's saying that pointer y is given at 300. What is this actually? What is pointer y 300? Okay, you know that y. Oh my god. Okay, sorry. Okay, so where is my question? Right, so I need to put my cursor somewhere around here lah. Okay, y point to address 300. Okay, all of you already get this. Y at address 300. Semua dapat Okay, so now we going to see, okay, analyze the program lines by lines, okay, instruction by instruction, which is from top to the bottom. Okay, so the first line here is include m32def.inc. So you include this file here to your program. Origin 0. Okay, you do the reset. Okay, origin with 0. Jump start. Okay, so it start. So this one here, it will go to your main program, which is this your main program, in which your main program here starting at address 200 in your program memory. All right. So now the first line here of the main program. Okay, LDI R21 8F. What is this actually? Okay, what happened here? So R21 equal to AF, right? And then load I R22 is 6, so you load value E6 to your R22. Okay, and then ASR R21. What is ASR? Can you tell me what is ASR? ASR. What the ASR do? Anyone?
Arithmetic shift right.
All right, arithmetic shift right. Okay, so arithmetic shift right. Okay, it says that, okay, you go to the what the note, your lecture note. It says that, okay, so this is your registers. Okay, you have 8 bits registers. Okay, it says that bit 7. Okay, you copy back your bit 7, and then after that you shift to the right by 1 bits. Okay, and value from bit 0 go to your C flags. Okay, this is ASR. All right, so bit number 7, you copy back the value of bit number 7, and after that you shift to the right by 1, while bit 0 here, the value from bit 0 will go to your C flag. Right, so in this case here, ASR R21. So what you're going to do here? Okay, you need to convert this hexadecimal to decimal to binary number. Okay, so what is the binary number for 8F? By using the add 4 to 1 method, so you know that it is 1000, and then what about F? 1111. Right, so next, ASR R21. What happened when you do the ASR R21? Okay, you copy back this bit number 7, right? It become 1, and next you shift your data from from left to the right 1 bit. Okay, so shift 1 bit to the right. Okay, so this will become 1 0 0 and 0 1 1 1. What about this bit here? This bit will go to your C
Carry.
flag. Okay, your carry flag. Right, so this is your ASR R21. Okay, you convert this value here, become berapa ni? C7. Alright, so this is C7. Okay, next, LSR R22. What the LSR do? Okay, what is LSR? Logical shift right. Okay, so what did the LSR do? Anyone want to help?
Shift everything to the left.
All right, so this is your LSR. Okay, I need to take. Okay, so LSR. Okay, so LSR, you know that this is your bit, right? So 0 from outside, we go to your bit 7. All right, and then value from, okay, and then it will shift to the right by 1 bit. Okay, the bit will shift to the right by 1 bit, and then value from bit 0 will go to your C flag. Okay, so now what is the value of your R22? R22 is E6 lah. Okay, so I put here lah. Alright, so E6, what is E6? 1110 followed by 0110. So this is equal to E6. Okay, and then you do the LSR R22.
IR15
Pardon?
You see the lines below supplies. Okay, line 11 and 11.
Line 11.
It is the
No, no.
that you found here.
No, we currently at
There is
LSR.
the R16. Okay, since you using the LDI, you cannot use the R16, R15. You need to use the R16 and 31.
Okay, now we are in line number 4, correct? Betul tak? Is it correct or not? Okay, we are currently in line number 4. Alright, so in this one here, alright, LSR R22. So LSR R22, what is your R22 value? E6. So E6, you convert to binary. Okay, you get 1110 0110. Okay, next you do LSR R22. So what happens when you do LSR R22? Okay, 0 from outside go to your bit 7. Okay, and then you shift this bit here to the right by 1 bit. Okay, it becomes 111 0011. What about 0 here? Go to your C flag. Okay, so what is the current value here? You get 7 3. Betul tak? Alright. And then STY plus R21. Okay, what is your value of Y? 300. Okay, STY plus. This is post increment. Means that you store first to this memory address. Okay, and after that, your Y will incremented by 1. Alright, so now STY plus R21, what happened here? At address 300, okay, you save R21. What is your R21? C7. Okay, all of you get R at address 300, you store C7. Semua dapat tak? Alright, next, STY plus R22. Okay, since this one here, after you store Y, okay, after you store this value R21 to address 300, Y will increase by 1. So Y now point to new address which is 301. Okay, so at address 301, you store R22. So the current value of R22, what is the current value of R22? 73. Okay. Can you follow? Right, next. We do the ASR again, R21. Okay, so this is our R21. We do the ASR again, so we copy back this value here, and then shift to the right by 1, 110, and this become 0, 0, 1, 1. What about this one here? Go to your carry flag. Okay, so this value here, what is the value of this one here? It become E3. Okay, so your R21 now have new value E3. Okay, and then LSR R22. Okay, again, this is the current value of your R32, which is 73. Okay, you put 0 at bit number 7, and then you shift to the right by 1 bit. Okay, it becomes 0, 1, 1, 1, 0, 0, 1, and this one here go to your C flags. Okay, so the current value of your R22 is 3, 9. Okay, next, STY plus R21. Okay, so what is the current location pointed by Y? 302 lah, because after you store to here, Y increased by 1. So now it's pointed to address 302, and then you store R21. Alright, so your R21 is E3. And then you store again. Okay, so this one will become 303. You store R22. What is your current R22? 3, 9. Okay, next we have ROR. Okay, rotate right. Okay, so ROR, this is ROR. Okay, what is ROR do? Okay, so you top one. Okay, this is your CO. CO will go to your bit 7, while bit 0 here will go to your C new. Okay, this is your C old, your current C. Okay, will go to your bit 7, and you shift to the right by 1 bit, and then this one will go to your, from bit 0 will go to your C new. Okay, so ROR R21. So R21, what is our R21? This is our R21, E3. Okay, and then now what are you going to do? Okay, what is your currency? Okay, your currency, you need to see here lah, your LSR R22. What is the C, the value of your C after you did the LSR R22, which is 1. Okay, so this one here will go to your bit 7, and then bit 7 will shift to the right to bit 6, and this one will shift here, here, this one shift here, 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 and here. What about this one? Go to your C flag. So this become C new. Okay, this is the previous C, and this is your C new. Okay, what is the current value of your R21? So now it become F1. Okay, next, ROR R22. So this is your R22 value, 39. Okay, so what is your currency? Okay, this is your currency lah. Okay, that you get, that you obtain from the previous instruction. This is your previous instruction. Okay, this is your current instruction that you want to execute. This is the previous instruction. From the previous instruction, you know that the C is 1. Okay, so now this C here go to your bit 7, and then you shift to the right by 1 bit, 001. This becomes 11, 0, and what about here? Go to your C flags, and then you get value 9 C. Okay, after that, store again. Store Y plus R21. So this is become 304. What is your R21? Which is F1. And this is 305. R22, the current value R22 is 9C. And then next, you have ROL. Okay, what is ROL do? Okay, rotate left through carry. Alright, so what happened here? Okay, this is the ROL. Right, C all, go to your bit 0. You shift to the left by 1 bit, while bit 7 here go to your C new. Okay? So now, you do the ROL R21. Okay, ROL R21. So ROL R21, where is ROL R21? What is the current value of R21? F1 lah. Okay. So, and then what about this currency here? The currency here, you need to refer to this one. Okay. The C after you execute this line here. ROR R22. Why? Because whenever you store, there are none of the flag are affected in the status register. Alright, you need to remember that. Okay, only arithmetic, data shifting, logical, and etc. will affect your status register flags. If you do the data movement, okay, like store, load I, your flags will not affected. Okay, so this is the C. Okay, what happened now? C go to your bit 0. Okay, your currency go to bit 0, and this will shifted to the left by 1. Okay, become 1, 0, 0, and this become 0, 1, 1, 1, and this one here go to your C. Okay, what is the value here? You get? Okay, this one here become E3. Okay, so now next ROL R22, again you do the same things. Okay, so what is your currency? This is your currency lah, 1. Okay, go to here, and it will shift it to the left by 1. 0 and 0. This one here will go to your C. Now you get 3, 9. Okay, next you store. Okay, again this become 306 will have R21, which is E3, and 307 we have value 39. Okay, we're not finished yet because we need there are 2 lines instruction left down here. Right, so what are we going to do? Okay, so this is a LSL. Okay, so what is LSL? LSL. Okay, logical shift right, left. Okay, so this one here. Okay, what the LSL do? Okay, again, you know that this one here, 0 will go to bit 0, and then bit 7 will go to your C flags. Okay, it's similar to LSR lah. Cumanya LSR rotate to the right, but this one go to the left. Okay, so LSL R21. So what is the current value R21, which is E3? Okay, so 0 go here, shift to the left by 1, 1, 1, 0, 0, 0, 1, 1, and this one here will go to your C flag. So now you get what value here? You get C6. Okay, meanwhile for R22, so this is the current value of R22. So 0 will go to here, the bit 0 here, and then this value will shift to the left by 1. Okay, it's kosong, kosong, satu, 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 and it's kosong. And now this 0 here will go to your C flat, and your R22 will have new value, which is 72. Okay, and next, you fill in the blanks. Alright, so you fill in the memory address and your register here. So this one here, where is, okay, so this is C7. Okay, and then this one here, 73. 302, you have E3. 303, you get 39. And what about this one here? F1. Nice. C E3 39 R21. Okay, so R21, this is the current value of R21, the last one, right? So this is C6, and last but not least, R22 is 72. Okay, all of you get this, the same answer here? Semua dapat tak? How many of you get the same answer? Okay, any question regarding this question 2? Ada soalan tak? If no questions, okay, next we go to the next question here. Alright, this one here you need to do a programming. Okay, previously you have a programming, you need to do analysis. Now, given a case or a problem, you need to do a programming. Right, so write assembly program to calculate the following equation. Okay, given a equation, y equal to minus 5x divided by 2. Okay, how to do that? Okay, and then it says that x is stored in the memory location of 400. Okay, you know that this x here store at the memory location of 400, and it is an unsigned number. Okay, so this is an unsigned number. Okay, this is the important information that you get from this what we call question here. Okay, while the result of equation y is returned to register R25, R24. Okay, so this y here, after you you finish the equation, the result we will store at R25, R24. Okay, how to do that? Okay, what are you going to do? Okay, first, you need to load lah. Load value from address 400. Okay, let's say lah x is your R70. Okay, let's say you assume that R70 is your x. Okay, so you need to load this value from address 400 to R70. So how to do that? What instruction that you're going to do? Okay, what instruction that you're going to use to load a value from memory address, okay, to your GPR? What instruction? Okay, we use the LDS. Okay, LDS R17. Why R17? Because you already assume that R70 is your X. Okay, from what location? From 08400. Okay, so now you know that this one here. Okay, so now, okay, X, the value of X are from address 400. Okay, next. Okay, this is an unsigned number. R70 is an unsigned number. Okay, next. 5. How to load 5? What instruction that you're going to use for 5? Okay, this, because you're going to do the multiplication here. 5x, okay, you need to do a multiplication. Multiply. And after that, you divide it by 2. Okay, we need to use LDI. But before you load this number 5 here to your register, okay, you need to take care of this negative sign here. Okay, how to do that? So this one here, okay, so you know that. Alright, so why not we put negative 5? So how to load a negative 5 to your register? Okay, you do the second complement lah. Betul tak? Okay, do a second complement. Okay, first you find out what is the 5 in the binary number. What is the 5 in binary number? 0 0 0 0 0 1 0 1. This is positive 5. And then how to get negative 5? From positive 5 to negative 5, you do the second complement. Okay, you from right to the left, you find the first number 1, you copy back that value, and the rest after that you complement. Okay, so this becomes 1 0 1 1 1 1 1. So this is your negative 5. Okay, which is if you convert back to hexadecimal, okay, you get F berapa ni? FB. Okay, FB equal to negative 5. Then after that, you can load this number to your register. Okay, let's say lah we load this number to LDI R18. Okay, OXFB. Okay, you put a comment here. Okay, so this is negative 5. Okay, this is the second line. Then, what are you going to do? Okay, you multiply negative 5 with X. Multiply that one. What instruction that you're going to use here? Some saying that MULS. What about others? Okay, I may say that MULS. Nick also say MULS. Okay, what about the others? Ada instruction lain tak that we can use here instead of MULS? Okay, so we using the MULSU. Why MULSU? Okay, negative 5 is your sign number. Alright, so this is sign number. While X, the important information there, unsigned number. So this is unsigned number. So that's why we're going to use the MULSU. Okay, because one number in signed number, the other number unsigned number. So how to write down this instruction? Okay, MULSU. Okay, starting with sign number dulu lah. Okay, you start with sign number. What is the sign number? Negative 5, which is from R18. And then R17. Okay, don't put R17 followed by R18, which is wrong lah. Okay, if you put that and then the equation here will be wrong. Okay, next, after you multiply negative 5 multiply with X, and then what you going to do? Divide by 2. Okay, so macam mana nak buat? How to divide by 2? Okay, before we divide by 2, okay, the result from this MULSU instruction will be stored at what register? Okay, after you use the execute the MULSU instruction, where is the result will be stored? Kat mana? R18. Okay, Amir say R18. Fira also say R18. Anyone? Alright, R1 and R0. Okay, remember, every time you use the MULS, okay, MULSU, okay, the result always store at R1 and R0. Why? Because you multiply 8-bit multiply with 8-bit, it will produce 16-bit number. Okay, so it will be stored at this register here. Okay, now you know that. All right. Since this is a 60-bit, okay, you know that this is a low byte and this is a high byte. Okay, next, the question is how to divide this result here with 2. Macam mana nak buat? You have, okay, okay, you will shift right. Okay, we have a few instructions to shift right. Which instruction that you going to choose? Why ASR? Kenapa ASR? Why not ROR? Right, because this one here. Okay, multiply. Sign multiply with unsigned number, you get signed number. So ASR will copy back the signed number. Okay, wait ya, I find the lecture notes. R0. Macam mana R0? What instruction that you going to use here for R0? Is it ASR as well? Okay, for R0, we're going to use the ROR. Why ROR? Okay, you see here why ROR. Okay, this operation combined with ASR effectively divide multi-bytes. Okay, you see here, multi-byte signed and unsigned value by 2. Okay, because why? Okay, if you recall back, this is your ASR. Okay, so this one you copy back, and what about this one? We go to your C, betul tak? And then the value from here need to shift to the R0. So since bit 0 now go to your C, so that's why we need to use the ROR. Because why? Because C old go to here, which is this C lah, will go to your bit 7, while this one will go to your another C new. Okay, if you're using the what we okay, if you're using the LSR, what happened is, okay, recall back, this is your LSR. Okay, what happened is 0 from outside go to bit 7, while this one go to your C. So how your bit 0 here, okay, this bit here need to propagate to, this is R1. Alright, this is R0, need to propagate to R0. Okay, that's why we use the ROR, not LSR. Okay, all of you clear? Semua dapat ya? Why I use the ASR and ROR. Right, so now we started with ASR first lah. Okay, ASR R1 followed by ROR R0. Okay, and then after that, what are you going to do? Okay, it says that the result of that equation, okay, must be returned to register R25, R24. So how to do that? You just use the MOVW. Okay, R25, R24 with R1, R0. Okay, you get 6 marks. Each of the line here, instruction here, will give you 1 marks. Okay, any question? Okay, maybe lah, you might wondering, but is it correct we use the ASR and ROR? How to verify that the instruction here is correct to divide, uh, to use as to use as to use to divide this number here by 2. Okay, how to verify that? Okay, maybe lah you can put some sort of numbers lah. Okay, let's say lah this one here, right? Kita ambil okay, to make it simple, let's say lah this one here 500. Right? 500, if you divide it by 2, you get 250. Okay, 500, you change to binary number, what value that you will get? Right, by using the 1, 2, 4, 8, 60, or you press the calculator lah, senang. Okay, 32, 64, 128, 256 and 512. Okay, you need 500. Okay, so 256 should be there. 128 also should be there. Okay, and then you plus with 64, plus with 32. Okay, and then you get, alright, something like this. Okay, so this 500. Okay, actually, okay, 1111 0100. This is kosong. 1 0 0 0, and you get 0 0 0 0. 60-bit number lah. Okay, we take a 60-bit number because this value here will be stored at R1 and R0. Okay, next. What about 250? What is a 250? Okay, 250, you 256 exceeded. Okay, so this 1 plus 64, and then plus with this one. This one. What about this one? 1 0 1 0. Alright, so this is supposedly to be your 250 lah. Alright, 1 1 1 1 1 10 10, and the rest will be 0 0 0 0 0 0 0 0. Okay, first, okay, this is R1, this is your R0. So R1, what are you going to do? We do the ASR. So this one you copy, kosong. Okay, this is your sign number. Okay, your sign value you copy back. Okay, and then you shift to the right by 1. So this becomes 0 0 0 0 0 0. And what about this one? This one we go to your C flags. Betul tak? Alright, then for R0 you use the ROR. So what happen is this value from C flag will go to your bit number 7. So it become 1, and then you shift to the right by 1, 1 1 1 1. This one go here, 0 go here, 1 go here. Okay, see, you get the same answers. Alright, so this is how you want to verify whether you use the correct instruction or not. Ada soalan tak untuk this question? Okay, if no question, I think I will give you another exercise. Okay, so now you are given this question here. All right, so you have a table. Okay, so this is the first table. Right, so this is actually your RAM lah. Okay, you see this is your data memory. and this is the content inside of this memory address, and this is your pointer register. Okay, and then given this program here, you need to analyze and find out what are the value after you execute this program here. Right, so let's look line by line. Okay, I just skip these 3 lines here. Okay, we're starting with this one. Load IR16 8. What happened here? Alright, so you make a counter register lah. So R16 you load with 8. This become your counter register. Okay, why you need a counter register? Because you see here you have a loop. Okay, so this become your counter register. Alright, next LDR70X plus. Alright, so now we need to know that where is our pointer register point to. Okay, this is a X point to what address? 312. Okay, this is your X point to the address. Y point to 41B. Okay, Y point to here. This is your Y. What about Z? Z is address 300, which is somewhere around here lah. Tak dekat sini. Alright. Next, LDR70X plus. Okay, you load value that point by pointer register X, put to R17. Okay, so let's this is your R70 lah. So R17. Okay, what address that point by X now? Dekat sini lah. 312. Okay, you get the value, which is A1. Put to your R17. And after that, what happened to your pointer register X? Okay, it will increment it by 1. So now it point to the new address 313. Alright, so X sekarang ni point to 313. No longer point to 312 because you already incremented by 1. Okay, next. Swap R17. What does swap do? Okay, you want to swap a position between low neighbor and high neighbor. Okay, this is what happens when you do a swap. Okay, means that this one here will go to position A and A go to 1. So they become 1A. 1A. Right? Next, ST minus Y R17. Okay, what is that? ST minus Y R70. You want to store to a location pointed by pointer register Y. Okay, which is store the value from R17. Okay, you see here, minus Y. You do the minus. Okay, you decrement the Y first, and then after that you store. Okay, so our current Y pointed to what address? 41B. Alright, because this is a pre-decrement. Okay, you need to decrement your pointer register Y, and then after that you can store the value to that address. Okay, so what happen is now it become, okay, so this is your Y. Okay, so sorry, I need to erase here. Okay, I put here lah, somewhere around here. Okay, so this is your Y. Right? So you decrement first. Okay, Y point to this address, part 1B. Okay, but because this is a pre-decrement, you need to decrement the Y first. So it become 441A. And then you store what value? R17, which is after you do the swap position. Okay, so become 1A. Okay, so now your Y point to this address lah, part 1A. Alright, and then decrement R16. So R16, current value R16 is 8. You decrement, it becomes 7. branch not equal, is it R16 equal to 0? If not, you branch. Go to this level here, up. If yes, you exit the loop. Okay, since R60 still have value 7, okay, so you need to go up here, load R70 with X plus. Okay, so what is uh, our pointer register X point to? 313. Okay, so you take this value here, 7C, and then your X will incremented by 1. Swap R70, so this becomes CA, and then store minus Y R70. So this become 419, and you store CA. Oh, sorry, not CA, C7. Sorry, C7. Okay, this one 7C. Okay, 7C. You swap position become C7. Okay. Next, decrement R16. R16 now becomes 6. Alright, branch not equal. Do again. Alright, load from 314, which is 83. Okay, now this one here go to here. Alright, so 83, you swap position. Okay, become 38. And then you store to 418. Alright, this is 38. Right, decrement R6, 7, sorry, decrement R16 now become 5, not equal to 0. So you go up again, okay, and then load the new number. If it is 23, go to your R70, then you swap the position. So this is 3, 2, and after that you store to your address that pointed by pointer register Y. So this become 417, and you store 32. Decrement R16, so R16 4 not equal to 0, do it again. Okay, so now, okay, currently dia kat sini. Okay, 316, so 316 which is 88. Okay, so now your X will increment by 1. Okay, then you swap position. Okay, dapat 88 and store to Y, so this become 416. Okay, and then 88. Alright, so decrement R16, so this become 3. Okay, so load again the value from 317, which is pointed by X, to R70. Alright, so you load 98. Okay, and then X will incremented by 1. And then what happened here? Change the position. Alright, become 8, 9. So store to location 415. Right, so it is 8, 9. So decrement R16 again. So this one here now become 2. Okay, not equal to 0. Load again the number. So FA go to R17. Change the position. Swap the position. So this become A7. Store to pointer register to address that pointed by pointer register Y. So this 414. A7. Decrement again R16. So R16 now become 1. Not equal to 0, load again the number. Alright, so sekarang your pointer register X point to the address. Okay, 319. So you get the value BC. Swap the okay, before we swap the position, X now point to the address. Alright, so this becomes CB, and then store the value. So this become 413, and this is CB, and decrement R16, R16 now become 0. Okay, when R16 becomes 0, do you need to go up here again? No, you exit the loops. Okay, so you now execute this line here, jump, exit, exit. next, what you're going to do? Okay, you fill up all these blanks here. Alright, part 19. Okay, part 19 you get. Alright, what is part 19? Part 19 is, alright, we started with, okay, part 1. For 1A is 1A. Okay, for 1A is 1A. This one is berapa tadi? C7 followed by 38, 32, 88, 45, 415 is 89, A7, CB. Okay, what about X? What is the current value of your X? X pointed to address 31A. Okay, 31A. What about Y? Y pointed to what address? 413. 413. What about 412? 412, you copy back the value lah. Okay, the previous value, 54. And as well as 41B also, you copy back the previous value, which is 69. Okay, 414 is AF. Okay, sorry. This one here, not A7, AF. Okay, 414, 414, 414. AF. Okay, thank you, Amir. Okay, any question? Ada soalan tak? For this kind of question. Okay, you need to analyze line by line. Alright? Okay, I think if no question, I think we can stop here. Okay, thank you class. We can dismiss now.